Alright, so I'm back here. In the last video I went ahead and created these variables down here, hooked them up to this lerp vector node, and we're basically going to do an alternative method of getting this stuff to work. So why are we doing that? Well, a couple of reasons. One, I want to show you that there's more than one way to get something to work with Blueprint. So basically you can do something using one method, and you can do the same thing using a different method or a third or a fourth method. There's just so many different possibilities. I mean, if you look at this, there's so many different nodes and so many potential combinations of them that you can literally create some kind of an action by using 5 or 6 or even 10 different methods for reaching the same result. The other thing I want to show you here is how to make variables editable to level designers or anything like that. So basically to make work easier for yourself or for any teammates that might be working for you in case you're on a mod team or you're in an actual studio environment and there's going to be other designers and things that look at this stuff. You can make their lives a lot easier by setting up and organizing public variables. So let's see how that works. So we have a variable here that I created in the last video called door closed, and it represents a position, a 3D vector. And then we have a variable here that represents door open. It's also a vector, and you can tell that because they're both yellow. So color coding helps us to determine what stuff is at a glance just by scanning it with our eyes. Okay, so I know that. So how do I get all of this stuff to work? Well, I'm going to go to the door open, and let's have a look at our component here. Here's our door. When it's closed, you could say that this would be position A. So the closed position, which is the initial position, is because the door is closed when you start, is position A. You could say that this would be position B because this is when the door is open. So this door could potentially be in one of two states, either A closed or B open. Alright? And we know from the previous videos that a value of about -300 in the z-axis works pretty well for opening the door, so about this much is going to work out just fine. So what we can do is we can go back to the graph, we can go to our door open variable here, and as a default set it to -300, which I've already done. Oops, just changed the value. We can also go to defaults here and you can change it here, so I'm going to go -300. Okay, so this is the door position when it's open. So now that we have that set up, this variable here represents 0 and this one here represents 300. So now what we need to do is we need to tell the door, okay, when you're closed, be at position A, and when you're open, be at position B. That sounded a little bit weird, but that's where we want the door to go. So how do we do that? Well, we do that with this same timeline here. If I open it, we have this door track right here that we had set up before. Remember that? And that's basically telling the door to move from position A to position B. And we're just defining that in here by, if I show you, position A is this little guy right up here, and position B is this guy right here, which moves to -300. What I'm going to do now is I'm going to create a new track. We're going to leave this one alone. We're not going to get rid of it. We're just going to create a new one. And this one right now, I might go ahead and rename this. So I'm going to call this door track vector, just to clarify things. And now we're going to create a new track. And before I do, I'm going to show you what I want to do. I want to create a new track that I can plug into this alpha slot right here in the lerp. Because right now we have a position A and a position B. We can use the alpha to tell Unreal, okay, at second 0, I want the door to be at position A. By the time we get to second number 2, or 2 seconds into the animation or the movement, I want you to be at this position, -300 units in the z-axis, so that the door is open. And the way we do that is with this alpha. But you notice that this alpha is green right now. That means that it's a float type value. What that means is if I take this door track vector and I try to plug it into that alpha, it's not going to work. You're going to see a little red mark and it's going to say, that's not compatible with float. You can't do that. It doesn't work. Which would be, I guess you could say it's like trying to stick a round peg into a square hole. It's just not going to fit however you try to jam it in there. So what we need one of these door track vector tracks, but we need one that's green. That way we can plug it into here. Now, the way it works is yellow is a vector and green is a float. Okay? So we're going to go back into the timeline and we're going to go up here. So here's vector. This is the original one that we created. We can't use that. But here's float. Well, guess what? We could use float. So I'm going to click on that. I'm going to call this door track, and this one I'm going to call float. And now if I go back here, you notice that now we have a door track float and it's green, which means that I can take this and plug it into that guy right there. Okay? Now, in order to make sure that this stuff up here isn't doing anything with this, because remember I have a door track vector. So basically what I'm doing is, let's pretend this is a light switch that turns the lights on in the room that we're currently standing in real life. What happens if you have two light switches on a wall and they both turn the light on? Well, things can get a little bit confusing, right? Why would you have two light switches that turn on the exact same light in the room? That doesn't make any sense. You need to talk to your contractor about that, because there's a serious problem with the way that they're building houses. So what we're going to do is we're going to turn off one of these switches. We already saw that the door track vector works, so I'm going to hold down the Alt key and click on that to sever the connection. That's how you can cut a connection between nodes, by the way. Just hold down Alt and then click on the pin itself. So now we just have the door track float hooked up right here. Now this guy is going to be controlling, helping to control our door, and right now it's not plugged to anything. You can see our return value isn't connected to anything. So what we need to do is take this vector and connect it to this vector, and there we go. Now everything should be working, right? Well, let's find out. Let's see what happens. I'm going to jump in, step in the trigger, and absolutely nothing happens. The door doesn't move, it doesn't flinch, it doesn't open, doesn't do anything. Well, that's because even though we have all this plugged in, the track that's inside of our door movement timeline isn't set up yet to do anything. If we look at our door track float, there's absolutely no data in here. There's no curve, there's no points, there's nothing. So what we need to do is we're going to go ahead and create some points. So I'm going to go over here, hold down Shift, and left click. I'm going to set this for the time 0, and the value will be 0. So this will start at 0. Then I'm going to go and create another one at about 2 seconds. And I'm going to make sure I put that to 2 seconds. And for the value, I'm going to set it to 1. So the way this works is, this is basically like going from 0 to 100%. So at 0, we're just starting off. By the time we get to 2 seconds into this timeline, we should be at 100%. Okay? So it's just an arbitrary value. And with that done, I'm going to go back here. So the way this lerp vector works, just real quick to remind you, it has two values. It's got an A and a B. Okay? The A right now, we're using it as the position of the door when it's closed, and the B is being used for the position of the door when it's open. Okay? And the alpha is controlling which one we're using, because we can't have A and B at the same time. We can't be basically at two positions in space at the same exact time. You can only be at one or the other. You can be at both, but it has to be at different times. See what I'm saying? So, for example, let's say I was going to go from New York to Chicago. There's no way I could be in New York and Chicago at the same exact time in space, right? Maybe tomorrow I'll be in New York and Wednesday I'll be in Chicago, or vice versa. But I can't be at both at the same time. So that's the way that this works. And the alpha determines when we're going to be here at A, or when we're going to be here at B, or when our door is going to be closed, or when our door is going to be open. And that alpha is being controlled right now by this curve right here that you see, this line. So at A, it's going to have a value of 0 right at the beginning of the timeline. By the time it reaches the end of the timeline at 2 seconds, it's going to be at 100% as opposed to 0. So 0% represents A, 100% represents B. That's just the way it works. So when we update the new location over here in the set relative location node, Basically, we're going to be telling Unreal, okay, right about now the door is closed. Okay, a couple of seconds has passed, the door should be open now. Okay, and the lerp allows us to fluidly move the door from position A to B without having it pop or disappear and reappear at position B, doing some weird teleportation stuff. Okay, so now let's jump in, see if this works. There we go. So the door is opening. If I step out, the door should close after a few seconds. There it goes. It's closing. Okay, so what did we just spend a whole bunch of time doing? Well, we just spent a whole bunch of time basically recreating what we already had up here, down here, using some different nodes and a different method. So you're probably wondering, well, why in the world waste time doing that? Well, I want to show you a different technique here. The cool thing about this little method is that we can expose these variables here and make them public. So what do I mean by that? Let's jump back to the level and select the blueprint. Okay? When we click on this blueprint, it's just one solid object. Say for example, I wanted to actually go in my level, look at this blueprint and go, you know what? I want to grab the door and I want to actually move it to a new position or change how much it opens and closes. Well, if I try to select the door, I end up selecting the entire blueprint. There's no way for me to just select the door by itself because it's part of the blueprint. If I try to move that door, the whole thing moves together. So that may be okay. It's not wrong, but depending on what you're trying to develop as a game or as a feature for your game, maybe that's not what you want to do. Wouldn't it be cool if we can just drop this blueprint in the level and our buddy who's a level designer on the other side of the studio or office or whatever wants to be able to control how much this door opens or where its door open position is? That would be pretty cool. But unfortunately, we don't have anything set up for that. The way we do that is using public variables. So let me show you how that works. What I'm going to do is go over here to my variables, and if I look at the door closed and the door open, you're going to notice this little icon here. It's probably easy to miss. There's a little icon on the right that looks like an eye when it's closed. If I go ahead and go to say the door open and I click that little icon, it's going to turn a bright sort of yellow color and it's going to have an icon of an eye that's open. Okay? By default, these guys are closed. What that means is that the variable is private. If I go back into the level, a private variable will not show up over here in the details panel when you select the blueprint. So if I select the blueprint, I get my details over here in the details panel, right? So I've got all these parameters for transform, rendering, input, all kinds of stuff. But I don't see my variable for door open or door closed. So what I'll do is I'll jump back into blueprint, I'll go to door open, and I'll click this little icon to make the eye. Another way you can do that is going down here to selecting the variable, going to the details. You'll see an editable option down here. If you check that off, the eye closes. If you check that on, the eye opens. So whether you use the eye icon or you use this little check mark, it does the same exact thing. So don't worry about it. Use whichever one you like. So now with the eye open, I'm going to compile this so it works. I'm going to save real quick and I'm going to jump back into the level. And when I do this, you're going to notice that I have a new parameter down here. It's called door stuff and it's called door open. See that? And it's got an X, Y, and Z because it's a 3D vector. You'll also notice that the Z is automatically set to -300. And the reason for that is because if we look at this variable, the default value is -300. So that's pretty cool. So in case you're wondering what happened, all we did was we exposed that variable to the level editor by making it public. Now, if we have a buddy on our mod team or our company, our game studio company, who wants to use this guy, they can just drop it into their level and they can have this variable right here so that they can play around with it and change how much the door opens. So for example, say I wanted to take this value and set it to -150, so only halfway, right? I'm going to jump into the level, I'm going to play, door's going to open, and then it's going to stop halfway because instead of going at 300, it stopped at 150, which is half. And now the door doesn't open completely, and now I'm stuck. Hey, let me through. So say for example you were going to use this door for an actual game, and this door is going to be, you're going to make copies of this door all over your space station, right? And there's lots of hallways, lots of these doors. Let's say you have a level, maybe one of these doors is set to open all the way. Maybe there's another door that only opens halfway because you have a point in the game, in the story, where maybe you got to go find a blowtorch to get the door open. So you go to the door, it opens halfway, and it gets stuck, and you play a sound effect of like metal getting stuck and gears having trouble working, right? And it's grinding and stuff. And then maybe a character from the story pops up over the radio and says, "It looks like that door's busted. You're going to have to find a blowtorch to cut through it or fix the gears or something." And now you got to go and explore the world and go on a quest to find a blowtorch or maybe a monkey wrench or something to get this door open. Then you come back, maybe there's a boss fight. When you beat the boss, then you get the door open and you move on to the next level. I'm just throwing out a simple example there. So exposing public variables is not only extremely useful, but it's a pretty standard method for game development. If you want to seriously develop a game, you need to understand this concept and you need to take advantage of it, because it's going to make your game development much easier and it's going to go much smoother and faster. So that's pretty cool. Now, another thing that we can do, which is actually really, really cool, let me show you this. We can go to this door open variable, and we can go down here, and you're going to see this option called Show 3D Widget. If I check that on, and it's turned off by default, so I'm going to turn it on. I'm going to compile the blueprint, jump back to the level. Now you're going to notice that I get this little thing down here. If I look at this, there's kind of this little weird wireframe like prism sort of object down there. It's blue, and it says door open. That's the name of the variable, which is this one here. This allows us to either type in the new value over here in the details panel by typing in, say, -150 or whatever it is, or we can actually click that little icon, which is called a widget, and now we can actually move it around. Now you won't see the actual door mover in the blueprint. You'll see the change once you play the actual game. So I'm going to set that to, if I look, I now set it to about -309. That's fine. I'll just do that. I'll jump into play. I'll open the door, and now it opens all the way. Instead of getting stuck in the middle, it opens to a full 309 units in this case. So this is another great way of helping out your level designers. Not only can they type in an exact value over here, but say they just want to eyeball something, a prototype, maybe it's faster, or they prefer to grab a little widget and move it around like this. They can just grab that widget and they can move it around and do whatever it is that they need to do with it. And that's pretty cool. It's a very powerful and awesome way of working with Unreal Engine 4. So that's how you expose public variables and that sort of thing. Cool. So the door works. Everything's working. This video has gone long enough. I'm going to go ahead and end this one here, and in the next one we're going to start to customize this a little bit more and add a cool little spin to it.